Now for question 3 we've got an integration problem here. We've got a repeated factor here, so we're going to write it as without the repeated factor and then with the repeated factor. And then for our linear factor we're just going to write it as c over x plus 4. This is our common denominator we're going to make. Notice for a we have x but we want x squared, so we need to times by x. And also we're missing this factor here on the end. For b we have the x squared, we just don't have the x plus 4. And for the c, we have the x plus 4, but we don't have the x squared. So we'll add that 1 in there. We've got the denominators the same here, so we're just going to make the numerators the same. And then now we can try and find the values of a, b and c using the similar methods we used in the previous clip. So, first of all, I see that 0 is a nice value here. So if I choose 0, this disappears. This one will still be here. 0 plus 4 is 4, so 4b. I noticed this was 0 as well, so that's going to disappear. So 4b equals 16 tells you that b equals 4. I can also choose negative 4. That'll make this 0 and this 0. Negative 4 squared is 16, so 16 squared equals 16. Therefore c equals 1. And then to find our last value, you're going to do that comparing coefficients trick again. So we'll use x squared. X times x is x squared, so we've got ax squared. There's no x squareds here. There is here though, there's c. So a plus c equals 16. We already know what c is. We know that c is 1. Therefore, what we can say is that a equals 15. And we have our expression. 15 over x plus 1 over x squared. Oh, sorry, b was 4. 4 over x squared plus 1 over x plus 4. Slight mistake on the end of that last clip. When we compared coefficients here, we said this equals 16. 16 is the constant though. This is not the number of x squared, so this should be 0. And therefore our value for a would actually be a plus c equals 0. If c is 1, that means a is negative 1. So we need to change this to negative 1. Now this question says integrate. So we've got 3 bits of integration to do here. And we've also got limits to put in here. Now the integral for 1 over x is ln of x. So we've got negative ln of x. This is the same as 4x to the negative 2. So when we integrate it, we're going to have 4x increase the power by 1 and divide by the new exponent. The integral for this, notice the differential is this. The differential at the top, the differential of the bottom appears on top, which means it's the ln function. So it's the ln of x plus 4, and this is between our 2 limits in the question, 6 and 1, and we'll substitute those in on the next step. So after we've done our integration, we're just going to plug in our 2 limits here, and it will give us this expression here. Now I notice the answer is in terms of a number and logs. So what I'm going to do here is I'm going to group my numbers together here. So negative 2/3 take away negative 4 is 10/3. And then I put all my logs together, but I put them in positives first. So positive, I got a negative and negative, which is a positive, negative, and negative log 5. Now using my rules of logs, when I've got anything that's added together, I can multiply those together. And anything that's subtracted, I can make as a division question. So 10 times 1 over 6 times 5, that's 10 over 30, which is the same as log of 1/3. Now using that same rule, I can also say that's log 1 minus log 3. And the ln of 1 is 0, and as you can see, I've indeed managed to prove what it asked us to find.